Thank you, Nikhil, for this kind introduction and the invite to present this topic that I feel very strongly and passionately about. To give a little bit of background, how I started thinking about this topic was during my 2018 and 19 distinguished lecture tour when I was going around the world talking about the real-time optimization for production engineers. I started getting some questions, some feedback, and then about the same time, I started working with some of the brilliant data science people as we were analyzing wells in different part of the world where I am from. And so that is where I started looking at some of the possibilities and gaps. If you're a production engineer, if you're an artificial lift engineer, if you're a facility engineer. So what you're going to hear in today's webinar is more about what are my thoughts on this topic. I'm not trying to tell you everything about what we are going to cover in the class and such. Class is a lot more hands-on than today's webinar. So here it goes. Nikhil has done a fantastic job, so I'm not going to regurgitate what he has told about it. So coming to the agenda for today's class, we are going to start by what is a digital transformation? What does it mean, right? And also then we will move on to what are the underlying technologies that enables digital oil field, followed by what are the data types in production domain and artificial because you cannot do analytics without data, right? So we have to know what we are talking about. What are the challenges with this data? What are the opportunities with this data? And I'll share with you a few case studies. Most of them are published. And I have done a lot more work in conventional as well as unconventional onshore and very recently with some deep water subsea wells. So in the class, per se, we'll have some opportunity to talk about some of those experiences, which I'll not be able to talk about today. So you can think of this as my learnings from a lot more smarter people and learnings from my errors. Okay. So when you open up nowadays, any of this, Nikhil, a quick question. Do you see the banner at the top that I see? Like you open up a Journal of Petroleum Technology or any other industry magazines, and you'll see that people are talking a lot about digital transformation. And even before people were talking about energy transition, digital transformation, digital oil field has been talked about for a lot of time. And there are some examples that I often talk about in my talks that even in 2010, there were presentations related to digital oil field whereby some of these big company names that you're seeing here, they claimed significant savings, significant higher production thanks to all the digital oil field, right? So my point is that whether you call it digital oil field, digital transformation, production optimization, it's all kind of adding significant value to oil and gas production producers' bottom line as well as the top line. And if your job is to work for one of these operators, either directly or in the service capacity, then it behooves of you to understand some of this, what I'm going to talk about. All right. So now let's talk about jobs. When you look into the operator landscape, whether you're a production engineer, process engineer, pipeline engineer, reservoir engineer, operator, or an asset manager, each of you have your job functions, each of you have some questions or some challenges or some opportunities that you're constantly thinking about. And I'm not going to read each and every bullet. Instead, what I'm going to do is that if you have to summarize all of these questions, concerns, opportunities, then it can be summarized in about 6 or 7 bullets like this. that are my equipment or wells delivering per plan? That is what everybody would like to know. Do I need to prepare or plan for any problems? Is there any failure that I can prepare for? Are there any specific aspect of my operating cost that I need to pay attention to so that my profitability becomes higher, right? Production forecast is, of course, everybody's interested because that's how we project how we will do in coming month or coming weeks or coming quarter, right? And when as your field becomes browner or even in the green field, you want to pay attention to, okay, where we have problem childs. And by problem childs, I mean which installations or which group of activities are causing shutdowns, which leads to production deferrals. So all of these questions can be answered, or at least that is the hope and expectations that you can use digital oil field based approaches. But everything starts with the data, with the sensing, what I call sensing. And when we say sense, what we are talking about is measurements of pressure, temperature, differentials, load, position, torque, etc., etc. The idea is that we want to understand how a specific equipment, how a specific process is behaving by different measurement. The same way when you go to doctor and then they take heartbeat, then they take temperature, or they look into your tonsils or whatever. So the same way we are trying to understand what is happening in our well, and what is happening could be more than 2 kilometers, 3 kilometers, 4 kilometers down the surface in a very, very small, slender hole, right? So first things first, we need to sense, we need to get some data to understand the health of our well, health of our facility, health of our equipment. Then comes how do we get all of those measurement to some location where we can comfortably analyze it. That's where communication, computations, and control aspect comes in. Um, and then you have to like transfer all of that data stream, whether it's in the abstracted form or in the raw format, all the way through some sort of firewalls into some kind of cloud-based or on-premise type of storage and computational platforms, where you have a bunch of people who are looking up whether they are IT, they are data analytics, whether they are data scientists, and of course the SMEs like ourselves, or if you are a decision maker as to where to allocate the capital. All of these people look at this data stream, try to make sense out of it, and then try to answer some of the questions, the kind of questions that we were talking about a couple of slides ago. Okay. So data analytics is all about making sense out of all of this measurement, merging it with business cases, merging it with whatever physics-based learning we have, and arrive at some judicious decisions, right? But first thing first, let's look at how this progression goes. And you might have seen this slide earlier when Nikhil was introducing me, right? So it always starts with surveillance monitoring diagnostics, where we put some sensors out there. When we have connectivity, we have lots of visualization dashboards that everybody loves nowadays because our morning meetings becomes easier with some of those Power BI or whatever is your visualization dashboard, or it could be one homegrown, right? But the real fun starts when you start doing some of the analysis. And this is the thrust of the course that we are talking about here, right? And the idea is that how we can make sense out of these data streams into some kind of guided workflows, centralized control, and smart alarm. And then the next step comes the optimization intervention in real time, right? Here, what we are talking about is adjusting the production as we begin to understand the health of the well, health of the facility. Similar, like the doctor, if you go and doctor says, you have this problem, why don't you start doing some diet remedies? And then we start adjusting our diet. The same way, why don't we adjust some production so that our wells and facilities continue to deliver in optimal fashion, and then they do not break down, causing some unplanned deferrals, right? And then comes the innovation, AI, machine learning. There is a lot of chatter about this. And this course, we are going to do lots of machine learning exercises, hands-on exercises actually, to give you a flavor of how you can take data stream from one end and then convert it into a model, a machine learning model that can be used, that can be put into production, etc. All right. But as Lord Kelvin said, if you cannot measure it, you cannot improve it. So let's start by talking about what are the data types in production. And here is this nice picture from Said Mubarak's presentation from many, many years ago, where he rightfully pointed out that for production and drilling guys, the data loops are very, very fast because you have to make some tactical decisions. Unlike if you are in the reservoir or G&G space, where your horizon is months and years, but even those decisions relies on the data generated during the ESP or during, sorry, not ESP, during the production or the drilling phases. But one thing you have to keep in mind is that in production, you have to be aware about the faster data streams, higher quantity data streams. So there are some special things that needs to be done, and that's what I hope to communicate in some of the slides. I'm just repeating the slide to reinforce the message that how the entire digital transformation comes together. There are What has happened in this century, I would say, is that increasingly companies are deploying subsurface sensors, and they could be some kind of downhole electronic or quartz gauges, which measures or senses pressure, temperature, and vibration, or very, very sophisticated fiber optics based technology where you're measuring the temperature or we are measuring the sound at every meter along the entire wellbore. Now visualize this, that when you have a point measurement like a downhole gauge or a surface gauge versus wellbore entire measurement with the fiber optic technology. With the fiber optic technology, you can get lots of data. One estimate is the distributed temperature sensing. When you are sensing every half a meter of the wellbore or so, you can capture something like a gigabyte per day from wellbore. And if you're doing acoustic sensing, then you can capture something like a terabyte per day from the wellbore. So my point here is that we, meaning the production facilities engineers, we need to prepare for this data torrents. The days are gone when we can just take one point measurement and try to arrive at the understanding as to what is happening. We need to have some real-time approaches, right? Now, of course, companies have invested heavily into some well site controllers, as I was explaining earlier. There are lots of variable frequency drives, data loggers, and increasingly we are deploying some edge devices. The idea is that whatever data streams are coming from our installations, they need to be somehow corralled, if I can use that terminology. And also some decisions needs to be made right there and then. And that is the function of this type of controllers or variable frequency drives or these edge devices, that there may be some built-in algorithms that can really make some snap judgment decisions. So and then with the edge devices, we have a lot more computational power available now, and we can deploy some of the sophisticated machine learning algorithms right at the website. And that is the beauty of the advances that have happened in last, I would say, couple of decades. There is a perfect storm, as they say, when we have advances in this semiconductor technology, we have advances in the communication technology, and on top of it, we have advances, significant advances into computations or the computing frameworks that allows us to handle lots of data. Now, one thing we have to keep in mind, unlike the consumer space, the amount of data that we are still handling is not that high. Imagine what would be the amount of data handled in companies like Netflix or Amazon. Compared to that, the data that we are handling, even though, as the next slide shows, we are getting lots of real-time point measurement. It shows that we have significant amount of data coming, whether it's an ESP valve, gas lift valve, rod lift valve, or plunger lift valve. But still, the data that is coming is, in my opinion, they're manageable. And the technology is there. The computational power is there to manage some of these data streams. And in the class, that is one of my objectives because what I often find is that people often come and ask me, where do I start running? What do I do? And then we do not want to start flying off the hook. So we'll start crawling. We'll look at some of the data points. We'll try to parse that data through some of the simple algorithms. And you can see that within 50 or 100 lines of code, you can make sense out of some data streams. And that is my objective in this class, not to give you everything, but give you enough so that you can start walking and I'll tell you, some of the classes that I have conducted, even I had some data science people who were attending it. And they basically took the script that we discussed, hooked it up to their company's data, and right there in the class, they showed it to the people, their company people. This was an in-house class, right? They showed it to them that how they can start analyzing some of the data right immediately. So that is the practical value one would get. But coming back to this seminar, what I'm showing here is that, and as I said earlier, we have lots of high volume time series data, whether it's a temperature sensing or acoustic sensing. Traditionally, people have looked at the visualization and nothing wrong in the visualization and trying to figure out whether the gas lift valve is open or not. And here is an example from Dubai where people use distributed temperature sensing as back as in 2007, meaning they were using it sometime in 2004-5 because they presented it in 2007. And very recently, this example came from North Sea, where this is a distributed acoustic sensing um, measurement presentation, if you will. And what this gentleman, and you can go and listen to this webinar if you're interested in this. Um, what he's trying to figure out is that he has less than 4 hours left because the rig is waiting, the data is captured, and he has to arrive at the determination whether the packer is leaking or there is a gas lift valve leak. And depending upon that, they have to provide an action sequence to the rig, right? So, what I'm trying to say here is that a human being trying to do this from oodles of the data. I mean, lots of data is not that easy. And now we need to work on some of the advanced algorithms to analyze this. And that's where some of the things that are happening in computer vision space, so-called artificial intelligence space, is going to help. But coming back to our simpler problem, other than the real-time data, you also need to pay attention to some of the discretized data. And what do I mean by that? Which is the production test, well test data, completion data, what type of PVT characteristics have been observed, what well activities have been performed, are equipment changed or not. These are all the data. These are not real-time data. And this data changes not as frequently, but they are very, very important when you're, if you try to just use real-time data, you might get some success, but it doesn't last very long. You have to merge some of this data with the real-time data in order to get better outcomes in your activity. This is a simple cheat sheet. You can come back and look at it. This gives you, at a glance, what would be a wish list, whether you're managing rod lift well, gas lift well, ESP well, what is your wish list of the measurement? Now, not everybody ends up measuring everything. Increasingly, what I'm finding is that the most of the companies are lowering enough sensors now to measure most, if not all of this, right? But this is your cheat sheet to understand what data sets are needed in order to analyze some of these types of the wells or in general in the production, right? So earlier in the introduction, Nikhil talked about what I'm focusing on is the failure analysis or virtual flow measurements, etc. This is the type of data that I play with day in, day out, right? Now, not all companies have all of the data, as I've been saying. Not all companies have such a high frequency data that also have observed. Some companies may be measuring their well test once every day. I have seen those, and some companies are measuring once every quarter. So, how do you overcome some of those challenges? Speaking of challenges, there are significant amount of challenges, as this graphic from Journal of Petroleum Technology or JPT says, that there are many ways this bad data can hold you back, whether it's there is inconsistency, incompleteness, ambiguity, or just plain wrong data that can be a big barrier to digital transformation. So let's look at some of the ways how the data can hold you back. So first thing first, many of us are aware of this type of reality whereby we have many analog gauges out there. And how do you digitize them? And asking company to invest in digitization, this can be a significant challenge, especially if you're brownfield with hundreds of wells or even thousands of wells. So that is one reality, right? Many times the key measurements may be missing. You may not have flow rate data at high enough frequency to do some meaningful analysis. Measurements may not make sense, like upstream pressure may be less than downstream pressure because of some recording errors. Measurement may not correspond to physical model. There may be some negative or out of range value, flatline data, clip data, etc. There are, of course, outliers always in the data set. Now, whether those outliers make sense or not, or they are just blips that needs to be ignored, those are really big challenges, right? And as I said earlier, cause for the quality and quantity issue with the oil field data is that the older infrastructure, many companies have that, right? There is a lack of information. There may be some malfunctioning devices. And then there are human errors, meaning somebody may have just recorded wrong equipment in the well set. And I have seen this, even though we would not like to admit it, right? So if you are going to do any meaningful data analytics, one takeaway from this slide is that you cannot just take data and run with it. You have to perform, you have to really take a cold, hard look at the data, right? Next challenges come, and this is more a concern from the data management side of it. And I have seen this as I work with companies in different part of the world that everything starts each of the groups in a particular company they have a very good intention that okay, we are going to analyze lift, we are going to analyze tubing performance, we are going to look at our processes, and each group ends up building up their own data sources, whether those data sources could be some spreadsheets, or they could be some SQL servers or NoSQL or whatever. But the point of this slide is that over the time, as you keep on building up those data sources, many of these data sources would have redundancies, duplication. Some data sources become go out of favor, meaning they may not have the most current data or they may not have correct data. And this becomes a bigger challenge. And this graphic is, by the way, from ConocoPhillips, Canada, where how they had to spend significant amount of time bringing the some kind of integration. And actually, I have an active project right now with a company in Latin America, where all we are looking at is how do we bring. Again, I'm not a data specialist. I merely look at the data from the perspective of a production engineer or a facilities engineer. And then I suggest what can be done, which data needs to be kept, which data needs to be thrown out. But this is something that you all need to keep in mind as you start your journey on this data analytics. Unstructured data is another challenge that industry has been working on. And when we say unstructured data, there's a lot of communication that happens via not only email, but via WhatsApp messages, text messages. If some field operator is out there, he's taking a picture of some equipment that is not working or there is some leakage or whatever, and then they send it to their boss. Guess where does that show up? It just ends up in boss's inbox or boss's phone. So tomorrow, if another operator or some other engineer looking at that well site, would they get access to that information? This is another challenge that companies and operators are working on. So this type of unstructured data can have lots of meaningful information. So how do we bring that into the fold? And then how do we use this information into our traditional analysis approaches? I do not have all the answers, but we will explore some of this. And I'm seeing some innovative approaches based on natural language processing. And nowadays we are using lots of large language models, what is called generative AI type of approaches to solve some of these problems, right? I already mentioned some vision-based system that can also help with some of these problems, right? So I talked about the challenges. Now in remaining 10 to 15 minutes, I would like to walk you through some of the opportunities. And by no means this is a complete list. Actually, this is based on some of my readings, some of my observations. Um, and I am showing you what is out there publicly available. Maybe not all, some of it, okay? But my point or takeaway for you from this section is that people have done this, people continue to do it. Not everything has been coming out smelling roses like what people claim, but there is significant progress. And if you feel that you have not been looking at this side because you're too busy doing your job, whatever that job function is, I would urge you to start looking at some of this, start learning some of this, because whether you like it or not, this revolution or this transformation is upon us. So please do start looking at that. So now let's look at one simple example. And this is from some of my previous work. And the point that I'm trying to drive here is that simple visualization of combined data set can help you overcome lots of things. So in the picture on the left that is coming up, what you're seeing in the bottom is some data streams coming from an ESP well. And then on the top, what you're seeing is some discretized event, the type of event that I was talking about it, whether it's a well test or whether there is some servicing activity that happened. When you look at some of these things, you immediately start isolating an activity or a group of activity that contributes to the uplift or deterioration on wells. Right? You can answer the questions like whether this new completion or new stimulation treatment was helpful or not, whether you need to change the gas injection. Is this a time for another scale removal operation? Oftentimes, people schedule these activities based on their past experience that, yeah, we do this every few weeks. We are going to ask our service company to come and perform this particular hot oiling operation, hot water operation. So now the question is, can we do it more efficiently? So when you try to do this type of visualization, and there are some innovative approaches that are happening in large language model space that can even get the answers. You can ask the question that, hey, the way you are asking question of Google or Siri, You can ask the question that, do you see some patterns that I can leverage for better business decision? Here I'm showing you some example of one SP paper that I co-authored with Luis Gonzalez on a Permian condensate well. And this was done more than almost 10 years ago or so. And what we are showing here is that what we observed when we started analyzing these few wells, what we observed in terms of downhole pressure and temperature measurement as the surface chokes were opened, meaning as the injection rate, gas lift injection rate was changed. But as you may be aware that some this unconventional wells, there is a lot of slugging and this. This was not a common knowledge at that time, even though it was being experienced by the field operators. And we started seeing this in our data stream. But our challenge at that time we were trying to solve was not related to slugging. When we have looked at that in one of the patterns that that I find later on. But our challenge was that with so much of fluctuations in downhole gauge readings, how we can come up with an appropriate productivity index and static bottom hole pressure. And if you are interested in understanding, there is a paper that we co-authored, that I co-authored. And what we essentially did was what people refer to as a hybrid analysis. Right? We ran some nodal analysis and used the outcome of those nodal analysis and compare that value against the downhole measurement. And it was a kind of a iterative process in order to come up with a reliable indication of productivity index and static bottom pressure, right? Later on, you'll see that very recently somebody has done something similar with the neural network, and I'll point it out. This one is something that I have done for many, many wells in unconventional space whenever I start visualizing. And it so happens that many of the operators in this space, they test their wells regularly, almost on daily basis. And then the question comes when and what you're looking at here is the total rate versus the bottom hole flowing pressure that was measured and then extrapolated to the depth of the perforations. And what you're seeing is that over the time period of just 2 or 3 months, how much of productivity decline is happening, right? So in that case, how do you come up with a reliable indicator of your static bottom hole pressure and productivity index? Just using about couple of hundred lines of Python code, you can come up with like a reliable estimate of this from hundreds of test data points. And this is what, as I said, I do that on fairly regular basis. Here are three papers that on the left side you see case studies related to machine learning for failure prediction or failure detection for ESP. I do not intend to go into the details of this paper, but I will just mention what is a common takeaway that you have to rely on not only static data, as I was mentioning earlier, but and dynamic data, meaning downhole gauge measurement, surface gauge measurement, motor controller, electrical reading measurements, etc., etc. But also you have to perform some computations using some well models, right? Using inferred production values, etc. When people use word inferred production, it is more like what I call virtual flow meter measurements. So all of this can be performed using data analytic techniques. Some of the techniques we discuss in the class that Petroleum Engineers Association is putting together, right? Here is another example, and we do discuss this particular example or other subset of this example in the class, whereby in the original paper, they analyze about 36,000 cards from 300 beam pump wells from Bahrain. And the idea is that use the machine learning to identify what is happening with the rod pump well downhole. And we will use a smaller subset of this data set to actually kind of data set to train some algorithms in the class and understand what the robot is doing. Now, what I am going to close this with is there are a couple of very, very recent uh, presentations. I shouldn't say presentations, but articles in Journal of Petroleum Technology, whereby Devon Energy, one of the main oil and gas companies here in the United States, uh, they regularly use this machine learning based system to compute the bottom hole pressure calculation. If you go back 2 or 3 slides when I was showing how we were using some of those hybrid approaches, here what they are doing is that they are training the machine learning models to estimate the bottom hole pressure and then applying that to the wells that may not have the downhole gauges. Very neat approach. The same similar type of approach using the neural network was done by these authors that are mentioned in this March 24 article in JPD. They use neural network to estimate the discharge pressure of the electrical submersible pump. And again, this is a very interesting work. And as I said, I have been also doing this, and we can explore some of this in the class. Okay. Continuing on, as I've been mentioning, computer vision, edge computing is becoming more and more prevalent. People are still kind of making a statement like it can shape, but I can tell you uh, a lot more is being deployed out there. It may not be if you're not come across, and if you think that it can never happen in my company or in my career, then I would say please rethink that and start paying attention to some of this. This large language model, everybody likes to make fun of Chat GPT, how it gives some hallucination and the answers that may not be valid or funny answers or so. And the idea behind such assertion is that it cannot be used. But I kid you not, this is increasingly being used by companies and in order to not only perform some research but into day-to-day decision making. And my personal experience has been using some of these LLMs. You can perform some of the coding that we are going to talk about in the class very, very quickly, even though you may not have enough coding experience. That is another objective. Why I'm doing this is that I'm telling people that, hey, you do not have to have FOMO, fear of missing out, or you do not have to have that, hey, I never learned how to do programming because some of these tool sets are so advanced, so powerful that with little bit of patience, you can do lots of work. Of course, you have to put in some effort, right? And you have put in such effort learning whether you are doing Prosper or Wellflow or I'm just throwing some examples of some simulators. So here is an example that ADNOC came out and said that they are unlocking $500 million using AI software. So it's AI machine learning. There are lots of business values being generated. So what should be your takeaway based on this seminar? First takeaway, production data is a must for this digital transformation. You have to carefully think, how do you contribute or how would you like to contribute so that sufficient and high quality production data is available, whether you are data consumer, data custodian, or data generator. Okay. And oftentimes you could be all three, right? Depending upon your role. Another thing is that what is your recipe for making use of real-time data set? You have to infuse the real-time data stream with legacy offline physics-based approaches, right? That is very, very important. What we are finding is that pure machine learning based approaches give you certain success, but when you marry it with these physics based approaches, your success of those analytic methods goes, it multiplies, right? This is another important takeaway that if you call yourself a production or facilities person, I don't have anything to do with data analytics. I'm not a data scientist. But please try to understand and embrace some of these emerging data science paradigms. Don't shy away from cloud computing, edge computing, Python, neural network, LLM, etc., etc. And you can ask some simple questions to the Gemini or OpenAI's ChatGPT. Hey, explain to me as you would to 5-year-old what is edge computing. So you can learn that way. You can also ask some of these tools, and they are freely available. Free. Just open up Edge browser or Chrome browser, and you can get access to some of this, right? You can develop your prototype code. The only thing important is that you have to think about what problem you're trying to solve. And you have to learn how to ask this LLM about solving that problem. And I can show you some of that also. I have also a message for data scientists that, hey, try to understand and incorporate field and domain knowledge because there is a lot of value. There are some heuristics that you can do. And with that, I think we have come to the end of my presentation. And Nikhil,